I will be discussing and applying 2 to the third factorial experiments to the field of electrical engineering. First, I will break down what exactly this experiment entails. 2 to the third factorial experiments are used mainly at the beginning of analysis to determine all the possible interactions 3 independent multi-state variables will have with each other. It is used in a way to lay out data and to focus on important statistics. Each part of the number, 2 to the third power, can be used to determine what is happening in the experiment. I will start with the base. The base part of the number, 2, determines how many states each variable can be in. In this case, each variable can be in 2 states. For example, if we chose a light bulb to be the variable, the 2 states it can be in are on and off. It is still the same light bulb, but it has different properties. The exponential part of the number, 3, tells you how many variables there are. In this case, there are only 3 variables. The last part we can learn just from this number is that when multiplying the power out to a single number, we get the total possibilities, or conditions of each variable together. For this experiment, there are 8 possibilities. So, 2 states, 3 variables, and 8 possibilities. This experiment is great for exploring the possible variations in their effects. So let's apply it. The company you work for, which makes RC cars, tasks you, an electrical engineer, with trying to fix a problem where the cars would have a power shortage and start to malfunction. You want to test the car with several different settings, and this RC car has 3 that draw varying amounts of power. The first setting is a speed controller, which has 2 configurations, turbo speed and low speed. Next, there are lights on top that can be configured to extremely bright and low glow. Finally, the car has a front-wheel drive mode and an all-wheel drive mode. We have 3 factors, each with 2 states that we'll be looking at. So now that we have everything we need, we can run the variables through the 2 to the third power factorial experiment, and what we get is a chart. Using this as a guide, we can now test the RC car with every available setting and get the probability of an electrical problem occurring. Even before we test, we can guess the combinations that will least likely and most likely have a power issue. These would be when everything is set to low and when everything is set to high. With our new guide, we can now start testing the RC car. In conclusion, 2 to the third power factorial experiments can help us as engineers to lay out testing categories. This experiment can be modified to fit more or less variables or states. As long as you factor in all the necessary information, this experiment can help you get started on many engineering problems.